Sanjay and Hariharan. I am waiting for some others to join.
Okay, ma'am.
Yeah. Vishal, why you didn't come yesterday? Vishal,
Yes, ma'am.
why you didn't come yesterday?
Ma'am, I was not feeling well.
You have to only sit at home, no? And attend the class. You could have just opened the laptop and sat by it, even if you are not feeling well. Because what
No, ma'am.
happens is
Yesterday
when in the
I went to
introductory,
hospital.
oh, what happened?
Maybe cold, ma'am. For past 3 days, I'm not feeling well.
Oh, so what did the doctor say?
No, ma'am. He gave some medicines, so I'm taking it.
Hmm. Okay, so I will start now. Vaishnavi, you are 5 minutes late. Earlier you used to start in time. Today you are getting a little late. Hmm? So you have to be in time because it is not one class. There are so many others. So we have to wait. It is not fair, right? So you must try to join in time. I don't want to start a class when all are not there because then you will miss out, right? Okay. Sai Kalyan, you are also generally punctual. What happened today? You are also late. So we did a few.
Yes, ma'am. Actually, I'm not in my home, ma'am. I came to my grandmother's home, so network issues.
Okay. Okay. So now we learned a few methods of preparation yesterday. So first we did ozonolysis from alkenes. So these are all questions on ozonolysis. Then we did from alkynes by addition of water. These are all ways of addition. Then we did from alcohols by oxidation. Then the fourth one we did from nitriles. Two methods we did from nitriles. One by reduction of partial reduction of nitriles. And then followed by hydrolysis. And the second is we used a new reducing agent, which is isodecanoate diisobutyl aluminium, which is like lithium aluminum hydride, but it brings about only a partial reduction of cyanides to, after Dibal H, you can convert, partial hydrogenation, and then you can use hydrolysis to get the aldehyde. Then we also did preparation of nitriles, preparation of aldehydes and ketones by using nitriles using Grignard reagent. So that is where we stopped. Now today we are going to learn preparation using, so this is the fifth method of preparation. And this is also a very important method. This is known as Rosen-Munz reaction. Since all the reactions which have names, you have to remember them specially. This is known as Rosen-Munz reaction. Now, Rosen-Munz reaction is a reaction where you use acid derivative. Acid derivative means something which has been obtained from an acid. So generally what you do is you take a acyl halide. Acyl halide means, see, this is RCOOH. This is an acid. So in this acid, if I replace the OH with Cl, then it will become RCOCl. This is called acyl chloride. So if I take my acid is CH3COOH, I replace the OH with CH, it will become CH3COCl. This becomes acetyl chloride. So all these acyl halides or acetyl chloride, they can, on partial reduction, the method is partial reduction. Okay, all these methods, they make use of partial reduction, because if I do complete reduction, then I get alcohol, but I want to stop at aldehyde. So the reaction is CH3COCl. You do reduction, you use hydrogen. And partial reduction, how you do? You use a poisoned catalyst, that is palladium and barium sulfate. Right? Then what happens? You will get CH3CHO plus HCl. This reaction is known as Rosen-Munz reaction, partial reduction with palladium and barium sulfate. So this is an acid derivative which on partial reduction with palladium and barium sulfate. Palladium is a reducing agent. It is poisoned with barium sulfate. This mixture of the catalyst, it is known as Lindlar's catalyst. Lindlar's catalyst is used for partial reduction of compounds. So here we start from acid derivative and you get an aldehyde. So whichever acid derivative that we want to use, supposing I take CH3CH2COCl and I do reduction with palladium and barium sulfate, which aldehyde I will get? An aldehyde with 3 carbon atoms. Just 1 minute. Hello? So I will get CH3CH2CHO plus HCl. Right? So that is the way you make aldehydes. Now this method, what is special about this method? It is used mainly to prepare aldehydes. So only aldehydes. And not ketones. You can't make ketones by Rosen-Munz method. Okay, so Rosen-Munz reduction cannot be used for making ketones. It is only to make the aldehydes. But from acetyl chloride, we can make ketones. But for making ketones, we will use a little slightly different method. And this method makes use of supposing I take CH3, CO, Cl. This is for ketones only. So if I take ketones only, then I can take the same compound, acetyl chloride or any acyl halide. But for making ketones, we use another organometallic compound like Grignard reagent. The compound that we use is dimethyl cadmium. Okay, so there it was magnesium, here it is cadmium. So if I use dimethyl cadmium, then I can prepare ketones from acetyl chloride. So it will become CH3, CO, CH3, right? 2 times plus CdCl2. Okay, so there can be methods for preparing ketones also. Now remember here we have used only those methods of preparation where we are preparing only preparing only aliphatic aldehydes and ketones. We have not learned to prepare benzaldehyde. There are 4 or 5 separate methods of preparation of benzaldehyde. We can take them when we do aromatic compounds separately. Okay, so this one right now we are doing only aliphatic. There is, however, one more method which is very important since I am telling you ketones with acetyl chloride itself. If I take benzene ring and I do acetylation CH3COCl in presence of anhydrous AlCl3, can anyone tell me what will be the product that I will get? I will get here acetylation COCH3 plus HCl. This is a ketone, but it's an aromatic ketone. Okay, how do I represent this ketone? C double bond O and CH3, right? This is called acetophenone. Okay, so we learned some methods, especially for acetophenone. Okay. Now we will take up the physical properties. Physical properties of aldehydes and ketones. So the lower members here, like methanol, it is a gas. Formaldehyde is a gas. And ethanol, acetaldehyde, it is a liquid. Right? So lower members, like aldehydes, they are gases, but ethanol onwards, they are liquids. Lower member like acetone or propanone is also a liquid. Okay. Acetone is one compound which is often used for nail polish removers. So that is a very good solvent which is used as a nail polish remover. If you remember that, then you can remember that acetone is a liquid. Now lower members, they are water soluble. So second important physical property is lower members are water soluble. So say for example, lower ketones and aldehydes, they can form hydrogen bonds with water. So what is a ketone or aldehyde? R, C, H and double bond O. And it can form a hydrogen bond with water. So because it can form hydrogen bonds with water, and that is why because this is a dipolar molecule and this also is dipole. So that because of dipole-dipole interaction, there can be solubility in water. But higher members, as you go higher, they are insoluble because the carbon chain, as the carbon chain increases, the solubility decreases. Okay. Now, how do you compare the boiling points of alcohols, alkanes, and aldehydes? See, alkanes, their boiling point. Now the third point is about boiling point. So boiling point of alkanes, that is the minimum, and then it is aldehydes, and then it is alcohols. Okay. So if the same number of carbon atoms, if I take ethane, will have the lowest, it is actually a gas, and then it is ethanol, and highest boiling point with 2 carbon atoms will be of ethanol. Why? Because here there is hydrogen bonding. Here there is dipole-dipole interaction. And here there is van der Waals forces, which are very weak. So van der Waals forces are the weakest, and then it is dipole-dipole interaction, and then it is hydrogen bonding. So accordingly, their boiling points change. So nothing much. Nobody talks about physical properties of aldehydes and ketones, nothing very important. We mainly should understand the chemical properties. Okay, chemical properties of aldehydes and ketones. So first, let us understand what is the basic type of reaction that they will undergo. So what did I say? All aldehydes and ketones will have this C double bond O group, right? So on the C double bond O, if I put both hydrogen, it becomes what? It becomes methanol. I'll revise this again. And if I on C double bond O, I put one CH3 and one hydrogen, it becomes ethanol. And if I take C double bond O and put both alkyl groups, it becomes a ketone. This is acetone. Okay. There are several ways. First of all, let us understand there are several ways that you can write them. You know how you write. That helps you in writing all the reactions. So you can write this as CH2 double bond O. Or you can write it as HCHO. All are the same. Or you can write it as HCH double bond O. These are different ways of representing the same compound. Similarly, here you can write it as CH3CHO, right? Or you can write it as CH3C double bond O and H, whichever way you want, you can write it. Ketone can be written as CH3CO, CH3. Even if you write in a straight line, C double bond O, instead of that, you can write it in a straight line. Or you can write it as CH3, C double bond O, CH3. So you should understand how to write them. Then only your reactions, you will not make a mistake. Okay. Then next one. Next thing that you should understand about the chemical properties. All of them contain which group? C double bond O group, right? So what type of reactions will they show? Since there is an unsaturation here, the type of reaction has to be addition reaction. So all of them will show very easy reactions. All are addition reactions. What type of addition reaction? They are called nucleophilic addition reactions. Okay, nucleophilic addition reaction. So if I write a general reaction, nothing happens to what is here. Only addition takes place here and here. So if I write a general reaction, C double bond O, and I have to write a reaction with any compound, like say, for example, I write a reaction with HCN. You only have to identify what is negative in the reactant. What is negative in the reactant? Cn is negative, H is positive. Here O is negative, C is positive. So what you have to do, add negative to positive and positive to negative. So what will be the product? C. Here you will get Cn and here you will get OH. So what happens is, you will notice that in all the reactions, what will happen? On the oxygen, always hydrogen will come. What will come on oxygen? A hydrogen will come on oxygen, always. And the rest of the molecule will attach to carbon. Rest of the molecule will attach to carbon. So let us see how the reactions will take place, these nucleophilic substitution reactions. So the first important point is, they will all show nucleophilic substitution reaction. The second point is that order of reactivity. Right? So ketones are the least reactive. Okay, ketones are less reactive than aldehydes. Okay, so as the alkyl groups here increase, or the size of the alkyl groups increases, the reactivity decreases. So ketones are less reactive than aldehydes. Then another thing is, acetaldehyde or ethanol is less reactive than formaldehyde, that is methanol. So as the number of carbon atoms here increase, the reactivity decreases. But still, all of them will show only one type of reaction, and that is nucleophilic addition reaction. So a nucleophile will add on carbon, and on oxygen, somehow from the reagent you have to find the OH, H, and then attach it to oxygen. So let us see the reactions. The first reaction is addition of HCN. Addition of HCN. What is the first reaction? Addition of HCN. Yes.
Ma'am, can you explain that last part again, ma'am?
This one?
Yes, ma'am. Why ketones are less reactive than aldehyde?
Okay, why ketones are less reactive than aldehyde? C. If I take C double bond O, and this is a ketone, right? And this is C double bond O and H, and here I have, this is an aldehyde. So here there are two alkyl groups, right? There are two alkyl groups which are having what? Plus I effect, right? So because of this plus I effect, what will they do? They will increase the electron density on oxygen. So the polarity of this bond will decrease. Carbon-oxygen bond will become less polar. And if it becomes less polar, the reactivity of that addition reaction becomes slower. So what happens is that if the alkyl groups are present, then the reactivity of ketones decreases. Here there's only one alkyl, right? So these are more reactive than ketones. In case of formaldehyde, there is no alkyl group. So which is the most reactive here? So as the number of alkyl groups increases, the plus I effect increases and the reactivity decreases. Okay, reactivity decreases because plus I effect decreases the polarity of this bond. If the bond is less polar, then addition will not take place easily. That is okay. Now you understood, Vaishnavi?
Yes, ma'am. Thank you, ma'am.
Okay. Then addition of HCN. So first thing is addition of HCN. Yes.
Miss,
Sai
plus
Kalyan?
effect will decrease the polarity and the electron density will decrease on this.
Yes. No, polarity means here electron density on oxygen increases, right? If electron density on oxygen increases, what will it do? It will, oxygen is anyway, this will become plus more electron density here, no? So this will, the positive charge will be, you can say, distributed or diluted, you can say. The positive charge will be diluted. Carbon's positive charge will be diluted because of the plus I effect of methyl group, CH3 groups. This carbon is normally, because oxygen is pulling electrons away, this is plus, oh sorry, this is minus, oxygen is minus and carbon is plus, right? Oxygen is delta negative and carbon is delta positive, right? Now, because of this being delta positive, this delta positive, it is slightly positive, but that positive charge will reduce. Why? Because of the plus I effect of methyl groups. So carbon will not be as positive, so it will not attract the nucleophile. Did you understand that now?
Yes, ma'am.
So addition of HCN. So first I will show the general reaction. So this is, and when HCN attaches, what happens? This is delta negative, this is delta positive. So H, this is plus and this is minus. So H will go to oxygen and CN will go to carbon. So what will be the product? You will get COH and CN. This is known as a cyanohydrin. Okay, so now let us see. I want to put here on this compound C double bond O, I will put a CH3 here. I made it ethanol. Ethanol plus HCN, what will I get? I will get CH3. C here, no change. And this is OH and CN. So what will be the name? I'll call it acetaldehyde cyanohydrin. Right? Supposing I take acetone, C double bond O plus HCN. Reaction will take place even if it is a ketone. It's only the rate of reaction will be slower, or it will be reactivity will decrease. Okay, so you will get CH3, CH3. Here C, this will become OH and this will become CN. So what will I call it? Acetone cyanohydrin. So it doesn't matter which aldehyde or ketone I take. If there is a C double bond O, then CN will attach to it by nucleophilic addition and I will get a product. So if I have a compound, say like this, right? And I react it with HCN, can I write the product? So it will be the same here, no problem. And here I will add, this will become OH and CN will come here. Okay, so across the carbon and oxygen bond, addition takes place. Always remember, hydrogen will go to oxygen and the nucleophile will go to the carbon. So there is always in carbonyl group, there is a C and a O across which the addition takes place. So hydrogen always attaches to oxygen and the nucleophile in the reaction will attach to carbon. So that is, now why is this reaction useful? You should also remember that. So supposing I take, now let me write it like this, CH3, CHO plus HCN. I can write it like this also. So what will happen? This will come here and this CN will come here. So what will I write? CH3, CH, OH, and here I will write CN. I have written it at the bottom, doesn't matter. Now I have also taught you that if I add H2O and H plus, what does CN change into? CN changes, in the last class also I mentioned this, CN will change into what? COOH. Right? So what did I make here? I made a hydroxy acid. hydroxy acid. What is the name of this hydroxy acid? Can you say? 2-hydroxypropanoic acid. So this is a very important conversion that we always do. 2-hydroxypropanoic acid. So hydroxy acids are often. You know which acid this is? This is the acid which is present in curd. It is known as lactic acid. Okay, so lactic acid is actually 2-hydroxypropanoic acid. So this conversion is often asked, how will you convert acetaldehyde to lactic acid or acetaldehyde to 2-hydroxypropanoic acid? So here also you are introducing a CN in the compound, a CN group, and you know how useful the CN group is. And how you are introducing? By making use of HCN. We are not using copper, silver cyanide or sodium cyanide. We are using HCN, hydrocyanic acid. Okay, so that was one. Now the second addition reaction, similarly, there can be several addition reactions. The second addition reaction of this one is addition of sodium bisulfite. What is sodium bisulfite? NaHSO3. Okay, so even if you don't know anything, by the help of what I told you just now, I will write the reaction NaHSO3. So what did I tell you? How will you write the product? In these reactions, always what comes to oxygen? Hydrogen. So from here, the hydrogen goes to oxygen. And what happens to the remaining here? SO3Na. Your nucleophile is SO3, and SO3, since it is minus, Na sticks to it. So this is known as a bisulfite. Compound that is formed is a bisulfite. So supposing I take CH3CHO and I reacted with NaHSO3, what will I get? I'll get CH3CH. Here OH, and here what will I get? SO3Na. What will I call it? Acetaldehyde bisulfite. Bisulfite of acetaldehyde. Now this bisulfite, you know, it is a crystalline solid. Crystalline solid. Right? Now, what is the advantage? Why all the reactions have some importance? What is the advantage of this reaction? The advantage of this reaction is this bisulfite that you get is a crystalline solid. If I treat this with HCl, I will get back my acetaldehyde, CH3CHO plus SO2 plus NaCl plus H2O. You know, it is like any sulfides when they react with HCl, dilute HCl, sulfur dioxide is liberated and you get this acetaldehyde back. So what is the advantage of this reaction? The advantage is that supposing I have a mixture of acetaldehyde plus ethanol. Okay, both are liquids, so I have a mixture of acetaldehyde and ethanol. Then what will happen? This, to separate acetaldehyde and ethanol, what I can do, I can treat it with a solution of NaHSO3. So what will happen? Acetaldehyde will form a white crystalline solid, and that crystals you can separate out, and ethanol will remain behind. So since ethanol will remain behind, you have separated acetaldehyde from ethanol. And how will you get acetaldehyde back from sodium bisulfite? Just treat it with dilute HCl. Sulfur dioxide will go out as a gas and you will be left with acetaldehyde. So this is a reaction which helps in separating the aldehydes from other compounds. By a chemical reaction, you can separate the aldehydes from other compounds. You are going to do this reaction in the lab whenever you do organic compounds, when you do acetone. This is one of the tests for acetone. So you will see, you take acetone, take sodium bisulfite solution, add it, in a test tube and shake it, the whole test tube solidifies into a crystalline solid. So that is the addition of bisulfite. Now the third similar reaction. Third similar reaction is which one of aldehydes and ketones? This time it is addition of alcohol. Any alcohol you can take, addition of alcohols. So this time you see C double bond O. Let us take an alcohol. The alcohol that I will take is ethanol. So CH3, CH2OH. So what will happen? First write the simple reaction. What is a simple reaction? Children, did I teach you ethers? All those who have been attending my classes, did I teach you ethers?
Alcohol, phenols, and ethers lesson, ma'am.
Yeah. Okay. So see here, what should come on oxygen? As I told you, H will come. From here, H plus, and this is minus. This will come on carbon. So you write here OCH2CH. Right? So this, what you call here, is known as hemiacetal, half reaction. Now this hemiacetal, if I write here again, COH, and here I write OC2H5, it can react with one more molecule of an alcohol. And this time water will be eliminated, minus H2O. So what will I get? C. Here I will get OC2H5, and here also I will get OC2H5. So this is why I was asking, do you recognize these compounds which have ether linkages? There are two ether linkages. Right? So what is the compound here that I got? This is acetal. Okay, and how does this reaction take place? By passing dry HCl gas through the solution. So this is addition of alcohols. So it doesn't matter which compound I begin with. So if I take again the example of CH3CHO and I reacted with C2H5OH, what will I get first? CH3CHOH, and here OC2H5. And when I reacted with more C2H5OH, I will get CH3CH, OC2H5, and here also OC2H5. I could do the same with the, say, another one, acetone, CH3CH3, C double bond O, and I could take another alcohol. Instead of this, I could take CH3OH. So I could have a similar reaction. First, I will get C here OH, and here OCH3. And if I do more reaction with CH3OH, what will I get? Interesting compound. CH3, CH3, C, OCH3, and OCH3. This is called hemiacetal. No. This is acetal. Sorry. Hemiacetal is the first one. Second one is acetal. Now, how do they twist this question? Similar, simple question, they may twist it. So like, for example, they will say, what is the reaction of acetone and ethylene glycol? So it is basically a reaction of an alcohol. So let us write CH3, CH3, C double bond O. And when I reacted with this compound, HOCH2, HOCH2, okay, this is ethane dial. Now you have to use your imagination and see what will happen. So this water gets eliminated, dry HCl gas. So you will get here, you call it a ketal. OCH2CH, right? This instead of acetal, we call it a ketal. Okay, so such reactions also are possible. Now, what is the advantage of this reaction? The advantage of this reaction is that sometimes you need to protect the aldehyde group. So whenever I get this ketal, what happens? The carbonyl group is now busy reacting with alcohol. Now when I add HCl to it, dilute HCl to it, I will get back my ketone. So say for example, I have a reaction CH3, C double bond O and COOH. If I react it with lithium aluminium hydride, what will happen? Both carbonyl and acidic group will get reduced. So what will I get? CH3, CHOH, and here I'll get CH2OH. But I don't want this to get reduced. So what I want to make is CH3, C double bond O and CH2OH. So I want to do reduction. I only want to reduce the acidic group and not the aldehyde group or the carbonyl group. So I need to protect this group. I need to protect the group. So when I need to protect the group, what will I do? I will react it with ethanol, say for example, ethanol. So ethanol will form an acetal and a hemiacetal and acetal, and it will give you the CH3C, OC2H5 and OC2H5 here, and COOH. Now if I do reduction with lithium aluminium hydride, what will happen? This group only will get reduced because this is already made acetal. So what will I get? CH3C, OC2H5 and OC2H5. And this will become CH2OH. Now if I treat it with HCl, I will get this group. So in between one step, what did I do? I protected the group. So that is the advantage of this reaction. Sometimes it is used to protect a particular group in organic synthesis when you don't want the other thing to get reduced. This is a little higher chemistry, but those who want to pursue a little more of chemistry, you should understand this, the advantage of this reaction. So I got three addition reaction. The fourth addition reaction. The fourth addition reaction is addition of Grignard reagent. Okay, this reaction I will not teach again. You know it very well. Aldehydes and ketones, when they add to Grignard reagent, what happens? They form alcohols, right? So how now you will understand better C double bond O. What is a Grignard reagent? CH3, say for example, CH3, or let me make it very general. So reaction with RMgX in presence of H2O. So what will come on oxygen? I told you always what comes on oxygen? H. So you will get OH. And what will come? The nucleophile, what is negative here, that will come on carbon. So you will get R. And if you remember all these reactions, you will recall Grignard reagent plus CH2 double bond O will give me primary alcohol. Grignard reagent plus RCHO will give me secondary alcohol. And Grignard reagent plus a ketone RRC double bond O will always give me a tertiary alcohol. But remember always on this carbonyl group, hydrogen will come on oxygen and R will come on the carbon. So whatever is the nucleophile, that will come on. Okay. So these are four addition reactions of Grignard, of aldehydes and ketones. So what are the four addition reactions? Let us do it once again. So the four addition reactions, we will just see them again. Addition reactions. Okay, and where are we making the addition? First C double bond O, second also C double bond O, third also C double bond O, and fourth also C double bond O. Right? And what am I reacting it with? First one, right? They are all what type of reaction? Nucleophile. So this is I have tried to make it of different colors so that it becomes easy for you. So this is HCN, the nucleophile and the electrophiles I have shown separately. Here it is on HOH. Okay, so how will the reaction be? This is right. So CO, 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 and CO. Now, what will always come on hydrogen, oxygen? It will be hydrogen. And what will come on carbon? The nucleophile. So what is the nucleophile here? CN. What is the nucleophile here? SO3 and Na comes along. OC2H5 and here R. Okay. The product that is formed what do you call them? This is a cyanohydrin. This is a bisulfite. This is a acetal or hemiacetal. First hemiacetal and then acetal. And this will be an alcohol. So you can see just addition here. You don't have to memorize. Whichever compound will have C double bond O, by addition you will get these products. Okay, so that is addition reactions. And what type of addition reactions are they? They are known as nucleophilic addition reactions. Nucleophilic addition reactions. Okay. When we did alcohols and aldehyde, alkyl halides, we were doing substitution. Here, what are we doing? Addition reactions. Okay, because we are dealing with unsaturated compound. Now we will take the second type of reactions. This is addition, this type of reaction, the second type 2 reaction. So this type of reactions are addition reactions, addition plus condensation. Addition followed by condensation. What is the meaning of condensation? When you remove a small molecule of water by reaction of two compounds. When two compounds react and a small molecule of water is then eliminated. Now these reactions are generally first, let us see what are the reactants that we can use here. Now this reaction, mainly we are, first type of reaction under this are reaction with ammonia derivatives. Reactions with ammonia derivatives. Derivatives of ammonia. Reaction with derivatives of ammonia. Now, here what do we do? First, let us understand what are derivatives of ammonia. What is ammonia? NH3. Now, in this NH3, if I take out one hydrogen, what will be remaining? NH2. Right? And instead of hydrogen, I put one group, G. So this becomes what? Ammonia derivatives. What are the different groups that I can put and how does the name change? So the first one here is NH2 and instead of G, I put OH. This one is known as hydroxylamine. Now please learn these names. Revise them. In next week's class, I'm going to ask you all these names. Hydroxylamine. B. If I make it NH2, NH2, it becomes hydrazine. Compound is known as hydrazine. The third one is NH2. Instead of one hydrogen, I put a big group here. Phenyl group. This is, instead of this one H here, I put NH and this benzene ring now. This is called phenylhydrazine. You can make many compounds. I am going to show only a few. NH2, here NH, and on the benzene ring you put nitro group. Right? So one nitro group here and one nitro group here. So you call it 2,4-dinitrophenylhydrazine. Hydrazine. It's also known as DNP, 2,4-dinitrophenylhydrazine. So these are all very useful reagents which react with aldehydes and ketones. Now, where do we make use of these reagents? What is the importance of these reactions? See, all these compounds, which products which are formed when they react with aldehydes and ketones, all products are crystalline solids. Remember, all products are what? Products are crystalline solids. Crystalline solids. What is the advantage of, they have a large volume and they melt they have sharp melting points. So the products which are obtained can be used to identify the aldehydes and ketones. They can be identified by these reactions, aldehydes and ketones. So we will look into that a little more. First, let us see the reaction. So now what is the reaction? So you have again a compound C double bond O. This is a general reaction I am showing. So this carbonyl group it reacts with your ammonia derivative, right? So how does the reaction with ammonia derivative take place? You have here H2N and G, the group, any group. So what will happen first? First, addition takes place. So how does addition take place? This becomes C. On oxygen, what will come? H, so OH. And what remains if I remove H from here? N, H, and G. This is the product. Now this H and OH, they will eliminate water. Let me write it in a little different way. So this is remaining from like this. So what will happen? This water will be eliminated. So minus H2O. So what will remain? C, and it will become double bond N and G. Now if I write like this, it becomes a little difficult. First, what did I do? Addition. And then what did I do? Condensation. Elimination of water. So effectively addition followed by condensation. Now instead of writing the two steps, easy method to do, what will it be? C double bond O, you write here H2N and G. And remove water here itself. Because I am not interested in the mechanism. I only want to see the correct product. It will be N and G. So this is how you get a product with ammonia derivative. Now let us write a few reactions and practice this. So first one, let us write a reaction of CH3CH double bond O with H2N and NH2. What is this? Hydrazine. Right? So what will I get? Remove water from. Right? So what will you get? CH3, CH double bond, N, NH2. Okay. So what is this compound called? Acetaldehyde. Instead of hydrazine, it changes into hydrazone. Right? So many names you have to revise now. I won't teach further unless you have revised all the names. This weekend, that is what you have to do. Now, supposing I take acetone and I reacted with H2N and this time OH. This is called hydroxylamine. Then what will happen? Water will be eliminated. So what will I get? CH C double bond NOH. These are all with by removal of water, minus H2O, minus H2O. So what is this compound called? This is called an oxime. So acetone, oxime, you call it acetoxime. Common names are easier to learn here. Acetoxime. Okay. Then supposing I react CH3CHO and I reacted with H2N NH C6H5. So what will I get? Minus H2O. So I'll get CH3CH double bond N NH C6H5. So I will call it acetaldehyde phenyl hydrazone, because this is what? Phenyl hydrazine. So all hydrazenes will change into hydrazones. Hydrazines will change into hydrazones. Okay. Now one which is a little complicated, but it is often asked. This is CH3, CH3, C double bond O. Now I want to react it with H2N, NHCO, NH2. This is called semicarbazide. Semicarbazide. What will I do? Remove water. Mechanically you do it. It's just addition, subtraction practice. So CH3, CH3, C double bond. Write the rest of it N, NH, CO, NH2. N, NH, CO, NH2. So this is called acetone semicarbazone. Right? They are all reactions given in your textbook. All reactions are not there. There is a table given there. And you have to just go through the table to understand the structure of the compound and the name of the product. Okay. Now you can see there are 3 or 4 common aldehydes and ketones. For each aldehyde, you can write 1, 2, 3, 4, 5, 6 different reactions. They are all of the same type. All of them are of the same type. We just remove water with the help of the hydrogen which is attached to nitrogen, not the hydrogen at the other end, not this hydrogen. Hydrogen which is directly attached to the NH2 group, okay, of ammonia. Remove water from there and get the remaining compounds. Just write it mechanically, and you may have to, yes, memorize a few names. If you can't remember the names, at least get the product right, get the product correctly. So that is reaction, that is the type 2 reaction. Reaction where aldehydes and where your aldehydes and ketones are reacting with ammonia derivatives. Okay. If I had to write, there are two typical reactions which I want to tell you. One is supposing I react acetaldehyde with ammonia. So then also I can write here H2N and here H. This is ammonia. So what will happen? I will get one product which will be the addition product. So that will be CH3, CH. This will become OH. This H will come here. And NH2 will come on carbon. So you will get this addition product first. You will get an addition product. This also can eliminate water minus H2O. And what will you get? CH3, CH double bond NH. This is, as I told you yesterday, this is imine. Now these imines are very useful compounds and they can polymerize. Now this particular one can polymerize, but the product is not very useful. When HCHO, CH2 double bond O, reacts with ammonia, H2NH, and if I remove water from here, you know what I will get? I will get CH2 double bond NH. And this compound, it polymerizes. And when it polymerizes, it gives CH2 whole 6N4. This is not in, not really mentioned in your book. So I don't think it can be asked in the exam. So don't bother. This is general, just general. I am telling you the use of this compound. This is a compound which is used in large scale. It is used for treatment of what is that disease known as? It is used for the treatment of rheumatism. You know, arthritis and rheumatism, people get pain in their joints. This is the medicine, simple medicine, which is used, which is prepared by the reaction of formaldehyde and ammonia. It crystallizes into this solid, which can be used as a medicine. It is called urotropine, right? It controls uric acid in the blood. Now, fortunately for you, there is no chemistry in everyday life. So that chapter has been removed. So you don't have to learn about these medicines. But generally, you know, chemistry, where it comes useful, I like to tell you. So I'm just telling you this compound is used for treatment of a very important disease. So I just mentioned it, not that it is important for exam. Okay. Who all left now? Wish. Next one. Say something, children. I get tired. I'm only speaking. Nobody is saying anything. Are you understanding? Too many reactions. Actually, according to me, you shouldn't have a class for more than 1 hour. Chemistry for more than 1 hour, it's too difficult to grasp or understand. Okay. So these were the reactions where you are having, again, they are all nucleophilic addition reactions, but here addition was followed by elimination of water. And so the overall reaction became a condensation reaction. Now we will learn, we will go further to the same type of reaction. Now only one more reaction I will teach you, which is, you can consider it as the, you know, sure reaction for the examination. So this is a, you know, I call it 10-star reaction. Very, very important reaction. So every year this reaction is asked in the examination. There is no exception. Always it is asked. This reaction is known as aldol condensation. Aldol condensation. So next 20 minutes, we will learn only one reaction, and that reaction is aldol condensation. So now the first important thing is that what are, you know, 4 important points in this reaction. First important point is, it is a bimolecular reaction. Bimolecular reaction. What is the meaning of bimolecular reaction? 2 molecules of the substrate will take part in the reaction. That means 2 molecules of aldehyde or 2 of acetone or ketone, 1 aldehyde or 1 ketone. So it's a bimolecular reaction. Then the second important thing is, it is shown by compounds, by aldehydes and ketones, which have an alpha hydrogen. They should have an alpha hydrogen. Only if they have an alpha hydrogen, then only they can show this reaction. Now, first of all, what do you understand by compounds with alpha hydrogen? Alpha hydrogen, what is it? So compounds with alpha hydrogen, they are CH3, CH double bond O, HCHO, CH3, C double bond O, CH3. Now What is alpha carbon first? Alpha carbon is the carbon which is directly attached to the functional group. So here, which is a functional group? CHO is a functional group. This is a functional group. This is a functional group. These are all functional groups. Now to this functional group, is there a carbon attached? First, let us see. Yes, here there is a carbon attached. This carbon here is what? Alpha hydrogen. Alpha carbon, right? This is alpha carbon. And the hydrogen attached to alpha carbon is alpha hydrogen. Now here, CHO. Now this has no alpha carbon. There's no alpha carbon. So this hydrogen is not alpha hydrogen. So this has no alpha carbon and hence no alpha hydrogen. Here there are two alpha carbons and each alpha carbon is attached to alpha hydrogen. So it also contains alpha hydrogen. Alpha hydrogen. Now supposing I take this compound. Benzaldehyde. Right? Now look at this, this is your functional group, right? Now this functional group is attached to what? This functional group is attached to a carbon here. There is a carbon here, right? There is a carbon here. So this carbon is alpha carbon. But does the alpha carbon have alpha hydrogen? No. So although it has alpha carbon, but no alpha hydrogen. Right? So which compounds will show this aldol condensation? Acetaldehyde and acetone. Formaldehyde and benzaldehyde will not show this reaction. So it is a bimolecular reaction. It is shown by aldehydes and ketones which have alpha hydrogen. That's point number 2. Now, a little more to elaborate this point, please understand. I told you there are two reactants, two aldehyde molecules which take part in the reaction. Of the two molecules, at least one should have a alpha hydrogen. So here I have written it's shown by aldehydes and ketones which have alpha hydrogen, at least one molecule. So if out of the two molecule, one has alpha hydrogen, it is enough. Now, when you look at the reaction, you will understand. The third important point here. What is the third important point? The third important point is that the reactant which is required for this reaction is dilute alkali. Dilute alkali means dilute NaOH or dilute potassium hydroxide. Strong alkali, but very dilute. Okay, then the fourth important thing of this reaction is what is the product in this reaction? The product in this reaction is an aldol. Product in this reaction is what? It is an aldol. What is the meaning of an aldol? Aldol is a compound which contains an aldehyde group plus alcoholic group in the same compound. Alcoholic group in the same compound. Aldehyde and alcohol in the same compound, then you call it aldol condensation. Aldol react. The product is known as aldol. Now let me show you examples of aldol. So supposing I have CH3, CHOH, CH2, CHO, right? So which is the alcoholic group? This is the alcoholic group. And this is my aldehyde. So this compound here that I have written is what? It is an aldol. Now there's one more thing you should keep in mind when you are looking at all compounds which have one CHO and OH are not aldol. The true aldol is one where the two carbon atoms, one which is a CHO group and the carbon atom which has OH group. Which are those? One here and one here. They should be separated by only one carbon atom. Right? The CHO and CHOH group should be separated by only one carbon atom. Then only it is a true aldol. So when you look at a product and you have to identify whether it is an aldol, you have to look at the CHO and OH. Okay, so these are the basic things and now let us see the reaction. Now in this reaction also, it has to be a nucleophilic addition reaction. Okay, so let us see how this reaction will take place. So supposing you have this compound, this is the substrate, first molecule. It is a bimolecular reaction. One molecule you don't have to bother whether it has alpha hydrogen because the addition will take place on C double bond. The second molecule should have alpha hydrogen, so I will take out the alpha hydrogen and write CH2, CHO. This is the second molecule. CH3CHO, I wrote one with as a alpha hydrogen. I took out the alpha hydrogen. Now, by what I told you earlier, what should happen? First addition should take place. So in addition reaction, what will happen? C, this will become OH. And the rest of the molecule, this is plus, and then this rest of the molecule is minus. So this will be the nucleophile. It will attach on carbon. Hydrogen has come on oxygen. So I will write here CH2, CHO. Right? So what did I get here? Aldol. So making an aldol is no problem. Okay. So if I write an aldehyde here, supposing here also CH3, CHO. Here what do I write? Plus HCH2, CHO. So how is it taking place? In presence of dilute NaOH. Dilute NaOH. Right? So what do? I attach this here and this here. So how can I show it? CH3, CH. This oxygen, I will take it down with hydrogen. And this CH2, I will attach here. CH2, CH. What is this? This is an aldol. Why? I just showed you there is a CHO and a OH and they are separated by one carbon atom. So this is a true aldol. How did it form? By nucleophilic addition of one aldehyde on another carbonyl group. Okay. Now this is known as which reaction? Aldol condensation. So this aldol, if I heat it, now water will be eliminated. Whenever condensation takes place, water is eliminated. So I am removing water. From where will I remove water? Now OH is already there, right? Now let me rub this out. So OH is already there. H will come from the adjacent carbon atom. And adjacent carbon atom means poor becomes poorer, the one which has less number. Here it has CH3, here it has 2. So what will I get? Minus H2O. So CH3, CH, double bond CH, CH. So this is a complete reaction. Aldol formation followed by condensation. What is the final product? You get an unsaturated aldehyde. This is called 2-butenal. Right? So I started with 2, I got a compound with 4 carbon atoms. It's a very important reaction, aldol condensation. This is a reaction when I had 2 molecules of both acetaldehyde reacting with each other. Now let us look at variations of this reaction because it's an important one, so you should know. Now I will make a variation. I will make my aldehyde this time CH2 double bond O. Instead of CH3 CHO, CH2 double bond O, and I will react it with again acetaldehydes HCH2 CHO in presence of dilute NaOH. So what will I get here? H, I'll take it down. So CH2, take this H down along with oxygen. So it becomes CH2 and OH, right? This OH will come down. And here CH2, CH. And if I write OH down, the advantage is I can easily remove water, minus H2. So what will I get? CH2 double bond CH, CHO, right? This is called acrolein. This has a smell of burning rubber, acrolein. Supposing I take one more now. I take CH3, CHO. But this time, instead of taking acetaldehyde, I take acetone. What is acetone? HCH2, COCH3. I took out one alpha hydrogen of acetone. So what will I get now? CH3, take this hydrogen along with oxygen, pull it down. So CH3, CHOH. And what is remaining here? CH2, CO, CH3. Now this OH and H from the adjacent carbon. So what will I get? CH3, CH, double bond CH. And here you will get CO, CH. So mechanically, you should understand what is happening. You don't have to memorize it, but you have to understand. And once you understand, apply it to different types of compounds and see what is a product that is possible. 4. Now let us make it 5. Now this time, let me take a reaction of CH3, CH2, CHO, right? And I want to react it with HCH2, CHO, acetaldehyde. What will happen now? CH3, CH2, CH. Again, bring these two. These two will come where? They will attach and they will come here. So you will become, this will become OH and this is CH2, CH. Now what? Again, remove water, OH and H. So what will remain? CH3, CH, CH, double bond CH, CH. Okay, so 1, 2, 3, 4, 5. So this is 2-pentanal. Pentanal. Okay. So like that, you should build up on reactions. If you were, I would have been so happy if I was standing there while you are writing the reactions to see how you are noting, and I would have made each one of you to write on the blackboard. Okay. So we did how many? 3. I'm doing this practice because I want you to understand it very well. Now I will take this time. This is the most challenging, CH2, CHO. This time I want to take 2 molecules of propanol. Propanol now, how will I write? Now here you remember in this propanol, this is the second carbon, this is alpha, and this one is beta. I have to take out which carbon? Alpha carbon and alpha hydrogen. So how do I write here? H will come out from alpha. So it will become CH, CHO, and here is my CH. It will not combine with the beta hydrogen with alpha hydrogen. So again, bring it down in presence of dilute NaOH. Write the product CH3, CH2, CHOH. Then write the rest CH, CH3, CHO. And now heat it and remove water. So OH and H from the adjacent carbon atom, which is less, with this one is less. So what will I get? CH3, CH2, CH, double bond C, and try to name all of them. C, H, double bond C, CH3, and CH. Okay, so That is how you prepare different reactions. This reaction is the one which is asked very often because children make a mistake of using the beta hydrogen for addition, not alpha. So you have to make sure that this beta hydrogen here. Okay. What is a mistake which children make? CH3, CH2, CHO, and then writes HCH2, CH2, CHO. Right? So if you do like this, then you will get the wrong product. This is wrong. Why is it wrong? Because this hydrogen is beta hydrogen. I need which one? The alpha hydrogen. Right? Now, when two molecules which are taking part in the reaction are not same, like this is propanol, this is ethanol, we call it crossed aldol condensation. Otherwise, aldol means both should be the same. Now there is another thing. Supposing there is one acetone and the other acetaldehyde, which will show the reaction. So now actually the more it is not, I mean, you have to decide which is more reactive. So you know aldehydes are more reactive than ketones. So alpha hydrogen of the ketone will add on the acetaldehyde. So what I mean is the last reaction, let us write the sixth one. Reaction between CH3CO, CH3 and CH3CHO. Now both have alpha hydrogen. So which will become the substrate? The more reactive one will become the substrate and the less reactive will give the alpha hydrogen. So what will be the major product? You can get two different aldols here. One, this the substrate and this giving alpha, the other, the aldehyde being the substrate and acetone adding on to it. So which is the major product where acetone adds on acetaldehyde. So how will I write? CH3, CH double bond O plus HCH2, CO, CH3. So what will I get? CH3, CH, OH, CH2, CO, CH3. And then remove water minus H2O, so OH and H. So what will you get? CH3, CH, double bond CH, CO, CH. Did you understand? So please look at this before the next class. Now there is one more week. Go through it and see whether you understand it, revise it. At least once before the next class, please go through it and practice it without looking at the notes, without looking at this, and then try it out. And I'll also try to send you some notes through your learning room. Go through that. Okay, thank you very much for all those who sat till the end. Thank you, Hariharan. You had kept your camera open. That's very good. And all others also who are present. Sai Kalyan, Vaishnavi, Vishal, thank you very much.
Thank you so much.
Thank you, ma'am.
Okay, bye, bye, bye.
Thank you, ma'am.
You're welcome.